Good afternoon, everybody. My name's Neil DeRogers. I'm with Mazak Corporation. No, I'm not going to try and sell you a machine tool today. However, I am going to talk to you about our iSmart factory in Florence, Kentucky. My background is manufacturing. I'm a machinist at heart. I'm a Microsoft certified developer, and I tend to have an interesting perspective on all of this, and I like to always bring my background in manufacturing into this, and something that we've done in our iSmart factory that I've really enjoyed doing is defining the use cases for IoT, Industry 4.0, and trying to bring new technologies to market. So some years ago, we got involved with the MT Connect Institute, promoting the new MT Connect standard, which I'll talk about. And the question came up, are you using this in your factory in Kentucky? And we weren't yet. So we said, you know, we have to start an initiative to use this new technology, define new ways of using it, and share this with our customers. Well, we wanted to make our factory a place where customers could come and learn about new technologies, how to get connected, and how to begin you know, on their road to IoT. So we call this the roadmap to IoT. So I meet with a lot of customers, and we sit down and we talk about, you know, what are their goals, what do they want to do, and they, you know, the IoT. I want to do Industry 4.0, and I'm always asking them, you know, specifically, what do you want to do? And they say, well, we got to do this, and we want to do this, and none of the answers they gave me are wrong, but they're always thinking, you know, we sit down and we say we want to think outside the box. We got to start thinking outside the box. And I borrowed this euphemism from somebody, and that is, get a whole new box. Don't just think outside the box. Create new technology if you need to. And that's what we did here at our iSmart factory. And we're using it today as a launch platform for IoT. And that's our Smart Box. So in the beginning, when we started moving forward with our iSmart factory, we've now defined two things that are constants. I don't care if you just want to do utilization, if you want to get data off the factory to go further on and do OEE, or overall equipment effectiveness. Maybe you want to do analytics on that data. Maybe you want to do preemptive diagnostics and do a big maintenance package on top of this data. It doesn't matter. Two constants. One, how do I get connected and do it securely? Two, what protocol or data model do I want to use to get that data? And that's really important. So first and foremost, we chose MT Connect as a data model. The reason why is that MT Connect is the only data model for manufacturing terminology. We got Spanish, we had a dictionary, right? Webster's Dictionary for Spanish, French, Japanese. Well, now we have a dictionary for manufacturing terms. Why do I want that? From an analytics standpoint, if you're collecting data from a bunch of different machine tools and they're all providing that data with different data tag names, you have to normalize the data before you can do analytics. You have to say, I have to make sure that all the terminology means the same thing, or I massage the data so I create that terminology. And then I often have to start making sure that the time is stamped. I have them sequentially in order from when they took place, and everything's synced up, right? We have the time zone issues, we got all of these clock issues and errors in clocks that we have to worry about. We have to make sure that the data gets normalized, and then we can start crunching the data. And that's why where MT Connect is really strong, is number one, if all your equipment is MT Connect compliant and reporting data in that data model, you have all the same data tags, and everything is returned with a UTC timestamp, which is Universal Time Coordinate, or Greenwich Mean Time, or Zulu time if you're a pilot. So having that data model is critical. I had a dashboard up there earlier, and you can see it over in the lower corner. If I walk into a factory today and they say, yeah, all these machines are MT Connect compliant, I can pull up my dashboard and I can monitor them all immediately. And the reason why is they all have that same data model. There's terminology across all of them, like controller mode and execution state, the rotary velocity or RPM of my spindles, things like that is all predefined, and I can read it. There's semantics, I understand it, and it makes sense. So from a dashboard standpoint, I can go in and every single machine looks like the same type of machine, reporting the same exact type of data, and it makes it really simple. So that makes dashboards plug and play. The way MT Connect works is the OEMs write what they call an adapter. And this can be either hardware or software, but that data is getting the proprietary information out of that equipment and pushing it and pumping data into what's known as an MT Connect agent. The agent is nothing more than a web server. It's a website. Okay? So we're pushing data in, we're populating this state engine or this agent, and it makes data available for any type of system or anything that you want to do. So on the side of a client application like Memex or any of these other products that collect data, they can go out and they can hit this agent and they can pull this information in just by using a standard protocol like HTTP. Now that's not the only type of transport that we can use for the data, but that is the default offering of the MT Connect Institute's reference agent. So I can open up a browser and I could go to a machine tool like over on the right, and you see this raw data coming in from a machine. The type of information would be controller mode, execution state, give me all the X, Y, and Z axis information like load, feed rate, temperature of spindles, vibration, any type of sensors you might want to add on top of that, you can do that. So it's extensible. I can add sensors at any time to machine tools. We've done it in our factory. Right now I'm doing coolant pH, concentration, temperature, I'm doing ambient temperature, vibration, and we can even do sound levels. So in my mind, I want to see a temperature map of my factory for quality. I want to see a sound level map of my whole factory so that I can point out this area needs air protection, hearing protection, and so on. I can do my own OSHA auditing if I wanted to. So if you look at Google, I go to google.com and I get this nice graph, and you look at it and I'm seeing visualization. Behind that visualization is data somewhere, right? And it's usually in the form of XML. You use XML every day whether you realize it or not if you use any Microsoft Office products. You know the extension for Word, DOCX? That stands for XML. So you're using XML every day and you might not realize it. But you go to google.com and you don't know or care that there's 10,000 other people at that same website getting different types of data, do you? As long as you're getting the information you want. MT Connect kind of works the same way. Because I have a machine on the factory floor, or maybe multiple machines. They're all MT Connect, which means they all have an agent representing them, a website. I can have a maintenance dashboard collecting certain pieces of information from all of them, just for maintenance purposes. I can have an OEE app like Memex that's collecting data from all those machines strictly for OEE and performance. So whatever you want to do, that data is available and you can all be collecting that data simultaneously. It's an open platform. So adapters come in different flavors. You can have a software adapter, like in the case of our Mazak controllers, it's Windows based. I put a piece of Windows software on there and it pushes data out to an agent. I'm MT Connect compliant. But you might have some other devices that are fairly old, some legacy equipment, and you want to connect to it using some electric wires. Maybe you're hijacking the stack lights on top of the machine because that's all you have for signals. That's fine. You put a little black box there that grabs the data. That little box acts like an adapter and it pushes data to an agent. And as far as your client application is concerned, it looks like a brand new machine. You're just getting a handful of signals rather than a lot of data. Once you have the information in an agent, there's your Google analogy again. I can have multiple systems collecting data out there and doing whatever they need to do. MT Connect is read-only. So there's a lot of argument about saying, hey, how do I get data to the machine, or if I want to integrate something with interfacing? You can do read-read. Now, in the early days of MT Connect, we started this idea of read-read interfaces between equipment, and Mazak and LNS did one of the first implementations of an interface with a bar feeder and a machine tool. And I was a naysayer. I was thinking it had to be hardwired and it had to be electrical signals. It worked just as fast and it was more fault tolerance. I had less problems with the interface and it just worked. Plug in an Ethernet cable and they was reading each other and they were handshaking, watching each other's data and their agents. So each system was reading each other's agent and responding to things that were taking place. And it was very powerful. So we were real happy with that. But from a security standpoint, we like that because somebody can't force data into our CNC controller and cause the machine to crash. That's really important for a builder because as soon as something like that happens, everybody points the finger. It's your fault. It's your fault. It's like, well, I know it wasn't MT Connect. I know that somebody couldn't push data in. I'm using MT Connect and it's read-only. So that's very powerful for us. We like that. At the iSmart factory, I have this concept I like to call pure MT Connect. And the reason why, I want every device on the factory floor to speak MT Connect. I want an agent there representing somewhere on the network, doesn't have to be on the machine tool, but I have a server and I put all my agents there for manageability, and they're connecting, I'm getting data off the factory floor from all the adapters that are pushing information from the devices. But if I have an agent representing every device on my factory floor, that means I have a layer there. I have a layer of abstraction that allows everything above it to be plug and play. If the software that I'm using for OEE, let's say I have a falling out with that company. No offense. let's say Memex doesn't want to, we're using Memex right now, but let's say in a year from now, we want to go somewhere and they don't want to go down that direction. What am I stuck with? Well, I can add another app and I can put it there and I can collect data from the agents and everything works side by side perfectly. Or if I want to implement a new version of their system, I can spool up a new server with their software on it, get it running, get it collecting data from the same agents, and then shut the other one off and everything just keeps working. It's not a problem. So having this layer of abstraction above the entire factory is extremely powerful. It makes everything upstairs plug and play, and I'm not beholden to anyone's particular technology. That's powerful for me. So today we meet with customers, and these are probably 5 of the top things we deal with. Number 1 is, where do the customers get advice? Right now it's just the OEE dashboards and so on, right? Viruses and malware on machine tools. You got Windows 95, you have Windows 2000, you got PLCs on the factory, all which from an IT standpoint are unknown quantities. There's like too much risk out there. I don't want to connect that stuff to my enterprise. This is a problem. You have hacking and ransomware. Whether you realize it or not, I talk to shops all the time when I do my 2-day boot camp, and I hear it all the time. Yeah, half our shop got shut down because of ransomware. We had to pull all the hard drives out and replace everything. They just cut their losses and replace the drives. It's happening. You hear about articles in, I think it was Wired magazine, where robots are being hacked from the internet. Okay, more and more I'm hearing that. I've heard 2 or 3 articles now about factories being hacked. Why is that? The number 1 reason is it's a very lucrative market for hackers. They hack you at home, they put ransomware in your PC, and they know they can get maybe $1,000 from you, right? That's about what you can say I'd be willing to spend to get my data back. What's the cost of a machine tool being down for an hour? $100,000, $250,000 per hour? That company will pay that ransom in a split second. And a lot of factories are even easier to hack than your home computer is right now, because they're just not looking at security. They're just hooking things up blindly without considering security. So it's really important to know what the benefit to these people are and why it's changing and why they're trying to hack. Intellectual property is a big deal. Any company that's doing DoD work, or any company that has CAD models and they want to share this information to their first-tier supplier, you should hear what they say. They say, we're so worried. We send this CD out, or even if we do a secure file transfer to the customer, once they have it, we have no control over it anymore. We don't know where this intellectual property is. We don't know where these CAD models are, and it really worries us that it's getting out into the wild. The last one is DFARS compliant. If you're doing DoD work right now, you have this thing. It's like ISO 9000, rules and regulations. DFARS has to do with controlling your information in your facility. In particular, unclassified technical information on the factory floor. So how do I secure my process data? I have programs that go to the machines, CAD models and stuff that's out on the factory floor. Simple process data like work offsets, tool offsets, information from metrology. Okay, anything that could be used to either reverse engineer or it could be used competitively, they want you to start locking that down. And there is a deadline for that this year. So DFARS compliance is becoming a big issue. Today there's about 3 different types of customers, in my opinion. One is this customer that wants to hook up a machine and do a simple dashboard. They just want to look at utilization. They're not storing the data. They just want to look at it and see utilization and ask the question, why is that machine red? Why is it not producing? The second type of customer is the ones that want to do something like OEE, or utilization, where they want to do calculated reports, they want to see charts, they want to see metrics, and they're collecting the data, storing it in a database for you, and they're giving you the capability of doing the reports. The third is a company that might already have an ERP system, and they want direct access. They want to get that data, push the data directly in there, and they want to have direct feedback. Okay? Remember this slide because we're going to go back to it. But the issue here is there's no security at the edge. There's something with IoT and Industry 4.0 that everybody is basically, whether you realize it or not, you're admitting, and that is that the data from the factory floor is now mission critical. I have to have that data from the machine tools, and I have to get the data from the PLCs or whatever it is, and the CEOs are turning to the IT people and saying, make it happen. And they're saying, absolutely not. This is a risk that we have a problem with. We don't want to deal with it. We're going to keep it separated. So today, the security plan that IT departments are using is a layered approach. I have a machine on a network. It may not be connected to anything yet. I have a shop network, a plant network, and this is a layered approach, and there might be a firewall at every layer, and they're managing it that way, and they give the factory its own network, and they say, you guys can do whatever you want out there. You want a PC out there, sure, but the data never goes into the enterprise. They never have it in the office. It's not going into the systems. It's not really integrated, and they want to get past that, or we want to get past that. So we have OT out here, and we know we want to get the data. As manufacturing engineers or manufacturing people, we say, I want that data, I got to have it, and this is what I want to do with it, and I can't get to it. The other problem is we have a lot of systems out on the factory floor that may be automation cells. And you have a lot of companies that, by today's standard, they put a cellular chip in there, and they allow a VPN connection out to the cloud as a service, and then Mazak connects to it, and the connection is made, and we can remotely administer that machine. By IoT and Industry 4 standards, that's no longer acceptable. That's a backdoor into the company, at least from an IT standpoint. The golden standard for connecting to a company now is VPN, and the reason why is that they can turn you on and off, they can audit you, they have full control over where you can go, they can create secure tunnels, and they know where you are at all times. That's going to be the method of the future to do remote diagnostics. So here's your IT department. They're saying absolutely not. We got a door at between the office and the factory, and they're saying, we're not going out there, but we're going to give you your own virtual local area network. We're going to give you your own VLAN or network out there, and you do what you want. So I got a couple problems. One, I can't get the data over there. Number two, if one of these machines catches a cold, they're all going to catch a cold, likely, right? They're all at risk of getting ransomware or viruses, whatever it is. I have to fix these problems. So we got together with Cisco. We were introduced, actually Memex introduced us to Cisco, and we collaborated and we said, look, here's the problem. We want to do secure connections. We want to isolate machine tools. And they say, no problem. We're the experts at networking. You know, we're going to do this. We're going to set it up. And I said, we got to go a little bit further than that. You know, we want to use open standards. We want to make sure that we don't look at it as just a security problem. We want to look at it as a manufacturing or OT use case problem. I got to be able to do this. I got to be able to do OEE, utilization, integration between automation systems, metrology, DNC. I need to be able to do secure file transfer. I need to be able to do all these use cases. Let's create a platform that will enable all of this to do it, everything we want to do today, and then make it as future-proof as we can so that if I want to expand on that capability of the platform, or the end users want to expand on that capability, they can, and there's nothing, you know, no secret Mazak soy sauce in there that says you can't change anything. It's going to be completely open. This is where the smart box came from. No, it's not a machine tool, okay? I like to consider it a byproduct of what we learned in our iSmart factory. So through the collaboration, we're saying this: I'm going to get security of my equipment through isolation. I'm going to put one machine. I can put as many as I want behind it. We limit it to 10. We tell you don't put more than 10 because we have 10 empty connect agents that run on there, and we don't want to go beyond that because of the amount of data flow. But physically, I could connect as many machines as I want. It kind of defeats the purpose of isolating a machine tool if I go put them back in all in that one big pool again, because if one of them gets infected, they're all going to get infected. So the best place is to have, or the best scenario is have one machine behind one box. But it enables a whole bunch of things, because in that box, I have a layer 3 managed switch from Cisco. And if you're not IT oriented, you may not know what I'm talking about, but this network gear is not like something you buy at Best Buy. It's identical to what they have in the office. If you go into the IT room, you see that rack of cables, you got all this rack of equipment in there. We basically took one of those, crunched it down, and made it industrialized, put it in the box. Why? Number one, it has a whole bunch of capabilities to it that IT can control. Number two, it gives us a security platform that allows us to customize it and configure it any way we want. And then we went one step further and we said, let's put a Linux kernel in there. Let's put a Linux PC in there that's very secure, that allows us to put what we call microservices. So if you think of Amazon Web Services, or you think of, you know, Microsoft Azure and all these cloud solutions, how is that all empowered? They use applications in little containers. Why? Because they're isolated, they're protected, they're very secure, and they can run anywhere. I can take one of those microservices and I can deploy it to my smart box, drop it in there, and I just create a new capability. So if you want to write a microservice that's going to add some extra capability and features to the box or to your factory, you can. So we're enabling you to expand on the box through applications. So I'm doing integration now with my enterprise. I'm doing utilization in OEE. I got all my agents running right there for all my machines behind the box. I want to do maintenance dashboard, or I want to record the data and do analytics and do preemptive diagnostics. I can. All of this data is flowing through there. But there's a big question mark there. One of the biggest hurdles that customers are having problems with today is they say, we want to do IoT. And they said, fine, give me a roadmap, define it, give me a budget, and then we're going to get it approved. They can't define it. 5, 10 years from now, they have no idea what the technology is going to be, and nobody knows where really it's going to lead. You know the basics. I want to do OEE utilization. I want to do product lifecycle management. You want to do all these things we know about today, but we don't know where it's going to go or how that's going to augment, how it's going to change. It's going to grow, certain areas are going to grow legs of its own, and you don't know what you're going to want to change here. So we want to give you a secure connection, and we want it to be fully customizable, and you can deploy it. How are we empowering that? We talked about VPN. The new golden standard for Mazak to connect to a customer is going to be through a VPN. And because that's a layer 3 managed switch, that means I can create a secure tunnel. IT can say, you can connect, and you can only connect between these hours, and when you do connect, the only thing you can see is that box, what's on the other side of that box, which means my Mazak machine. And that's it. That's powerful. They're restricting you. I'm not connecting to their whole entire network. They're saying, you're only going there. The other thing is I got a guy sitting there, an NC programmer, and instead of putting a program or some software, whatever it is he needs to bring down to the factory floor to that machine on a USB, he does a secure file transfer. He encrypts that file, he connects to the smart box, and he says, I want to download this file, and boom, it drops right down onto the hard drive of the machine. I'm demoing it over here, actually, and that's why we have the controller and such. So I'm dropping the file right down onto the machine, and now there's no USB. There's nobody walking around with this volatile data or this intellectual property that you don't want people to have. What if I have a first-tier supplier and I want to do that with them? I no longer want my intellectual property going out into the wild. Mr. First-tier supplier, I want you to lock down your equipment so that I know you're secure, and then I'm going to VPN into your facility, and I'm going to download that cutting program to make my part for your machine. I'm going to download it, and now you make that part. And when it's done, I'm going to remove it. That's powerful. That's the type of things that customers are asking for because they're trying to get control of their intellectual property. So these applications that we're running, what else do I want to put on there? I might want to add some other capabilities. This also gives me the ability to do edge compute. Think about March Madness, right? Everybody at the company starts watching the basketball games, and everybody's streaming the games, and next thing you know, everything stops. Why? We were taking up too much bandwidth, and the IT department shut it off. They said, hey, you're stopping business here. You guys are taking up too much bandwidth. The same thing happens when I put sensors on this machine. Everything's going to sensor. Anybody that tells you that you can take all of this high-frequency sensor data on a machine tool and send it to the internet, and we say, we're going to send it to the cloud. The cloud is where everything's going to do. Unlimited compute power. I know a situation right now with a customer where they're doing that, and they literally had to shut everything down because this was generating, with all the machines they had on the factory floor, it was generating so much bandwidth that they have a problem. The smart box solves that problem because I'm isolating that machine. I have all this high-frequency data there. I'm doing vibration, I'm doing temperature, maybe I have multiple vibration sensors, okay? And I want to do analytics on the machine. I want to see if something's about to fail. That's fine, but that's so much data. I'm going to do it here. I'm going to drop an industrial PC on the DIN rail that's in the box, and I'm going to calculate it right there. I'm going to monitor the data on this secure network on the southbound side of the box, and when I see something happen, I'm going to send a report. I'm going to pump it out MT Connect, and I'm going to send out a report. This took place, this happened, I had an average data of this, whatever, and I made an offset to the machine, whatever it is. Now I'm doing preemptive diagnostics, I'm doing streaming analytics at the edge. I'm doing true edge computation or edge compute. This is the type of things that these use cases that we're defining with our customers, and we're saying, you know what, this is real, we can do this. We're already expanding on our original idea, and we're empowering our customers to do really cool things. But there's also another problem, and it has to do with scalability. Yesterday's method of connecting machines was just plugging it all in, and then they said, well, wait a minute, we have a security problem. Well, I'm going to buy these black boxes, and I'm going to put them on there, or I'm going to create some little black box, I'm going to put it on there. But eventually you get into hundreds, maybe thousands, typically hundreds of these boxes out on the factory floor, and you have no control over them. Do they need a firmware update? They're truly a black box because I can't scan them necessarily. And from a security standpoint, they call it a black box. It's got to go behind a firewall. They got to isolate it. You might as well not have it because it's useless. So how do I manage having all these boxes out there that I don't know where they are? Maybe the person who installed them left. You got to have a means of managing it. So from a Cisco standpoint, they open up their fog director and they say, boom, here's all my smart boxes, my layer 3 managed switches. Here's all the firmware on them, and I want to deploy a firmware update to them. I'll do them on the off hours, and I can schedule them. When it comes to the applications, I can also deploy the applications out to all these boxes. Maybe I have a new app that I create, and I can deploy them, or an update, and I can deploy them any way I want. So I've got one guy sitting in the IT room managing all the security for the boxes, deploying apps, deploying firmware updates, and he can do up to 100 and something thousand units, all from one dashboard. That's scalability. That's the type of control that you want to have on your security in the factory. So now we go back to that screen I had of the 3 types of customers. All I've done is added a smart box there, providing the security. I'm still enabling all the things that you want to do. I'm not telling you to do this my way. I'm not telling you to use my software product or my, do IoT this way. What we're doing is giving you a secure platform for IoT that allows you to do whatever you want to do on the northbound side. If you have a system that you have in your factory and you say, this is something very unique to our company and it has to be able to communicate to that machine directly, I can create an exception, just like you do with a firewall. Your IT department can say, that's fine. I'm going to allow that computer, that port, that software to communicate with that machine, that port, that software, whatever. And they can isolate it, very specific, and you make an exception. It's perfectly fine. It's not blocking anything that you're doing today, but you want to do as few of those as you have to. If you start at the edge, down in the gutter there, right by the machine tools, and you start right, and you do security correctly, and you have an open platform that's something you can grow with, anything that's you want to do today that you know about, and anything you want to do in the future, you're going to be empowered to do. And that's really what the Smart Box was about. Trust me, we had no intention of going into the IoT or the networking area, okay? This is something that literally became a byproduct of what we were doing. If you go and do something simple, and you buy something proprietary, and you buy something that's a black box or whatever, it may solve one use case, it may solve multiple use cases. It's not going to be future-proof. It's not going to give you everything you want to do when technology changes. It's not going to allow you to drop a Bluetooth receiver in there. It's not going to allow you, there's all kinds of things that you may or may not want to do in the future. But it will limit you to some extent because it's not an open standard. Everything in that box is off the shelf. If you try to reproduce that box yourself, you might pay twice as much. The box is UL listed. We paid a lot to get it UL listed. It's NEMA 5 rated. It can run anywhere in the world. It'll accept 100 to 230 volts, which means I can run it in Europe or in the US, doesn't matter, just change the plug. And it's wide open. So add extra stuff, come up with as many crazy ideas as you want to do to expand it, and it's likely it'll enable it. We've already got new ideas for things that we want to do that customers are asking for, and they say, can it do this? And I'm like, yeah, we can make that work. It's there. So it's just a base starting point. So think about that. We do have an MT Connect boot camp that we run every quarter. We have one coming up October 17th and 18th. It's in Florence, Kentucky. You don't have to know anything about MT Connect, but we start out first day. What is MT Connect? What can I do? Kind of the value proposition. Crawl, walk, run scenarios. How to get started. We talk about security. And then we tour the iSmart factory. And you guys can ask questions. You get to see the sensors. You get to see the smart boxes being used. Everything we're doing. The second day we talk about what's an adapter, what's an agent, how to query data, and how to install it. If you're an IT person, that'll be right up your alley. And we try to give you the jump start on MT Connect. So that's coming up October 17th and 18th. At this time, I'm going to open up the floor for any questions that you might have. I did such a good job, nobody has any questions. Great. Thank you very much for coming.